Hello everyone, my name is Abraham and in today's video we will talk about Kirchhoff's laws. So let's get started. Okay, so the first question that always comes in our mind, why sir, why are we learning one more extra law? So before I answer that question, let's try to recapitulate what are the things that we studied in the previous video. So in the previous video we talked about simple circuit, right? And this is an example of a simple circuit, right? Okay, so what is going to happen here? The current will start from the positive terminal, right? It will flow in a cyclic manner and it will come back, right? So from the previous video, we got to know that there is some kind of terminal voltage across your, across your cell, which is given as V is equals to E minus I times of R, where your V is what you call as your terminal voltage, right? So this is your terminal voltage, right? Okay, E is what you call as your EMF, electromotive force of your cell, and small r is what we call as our internal resistance, that is the resistance offered by the material of the cell or battery. Yes or no? These are the things which we have already studied in the previous video. Also, we derived the formula for current inside the circuit, right? So that formula was, if you guys remember, I was equal to, yes, EMF upon external resistance plus the internal resistance of your battery. So this is something which we have derived in the previous video. For all those people who are not understanding this, you can go back to the channel, watch that video and come back here, right? Okay, also we also derive the formula for internal resistance, which was coming out to be R EMF upon terminal voltage minus 1. So these some formulas which we actually did in the previous video. I hope that is understandable to everyone. So we were able to find out the value of current that is flowing inside a circuit. We were able to find out the value of internal resistance. We were able to find out the value of terminal voltage across your cell. Is that a yes or no? Okay, now let's go back to the question that we were supposed to answer, that is, why are we learning one more law? Why should I learn Kirchhoff law? What Kirchhoff law can do to us? Okay, now this was a simple circuit, right? Now we all know life is not simple, right? So this circuit is a very simple circuit. Now in our life we will encounter complicated circuits, right? So okay, so simple circuit, for a simple circuit you can simply use these formulas and you will get the answer very nicely. But what will happen if the circuit is a little bit complicated? For example, let's take a example of a complicated circuit. So this is a little bit complicated circuit. Why it is a little complicated circuit? Because we have two cells over here. It can be n number of cells, right? As the cells increases, the complexity of the circuit increases. So right now I have two cells. I have no clue how the current is going to distribute over here, right? Should I start current from this cell or should I start current from this cell? No idea. Or should I start current from both the cells? What is going to happen? So what will be the value of current over here? No idea, right? What is the current that is going through this resistor? No idea. I cannot tell because I do not know. I do not know how to do that, right? So in order to solve, in order to find out the values of current, voltages across these kind of complicated circuit, we use Kirchhoff's law. Kirchhoff's laws are very useful in order to analyze your complicated circuit such as like these. I hope you guys got the answer to that question, that why are we learning a new law? Because Kirchhoff's law is very much useful to solve complicated circuits, right? Okay, great. Now Kirchhoff's laws are not as difficult to understand. The only thing is that there are basically two laws. Kirchhoff gave two laws, that is Kirchhoff's current law, Kirchhoff's loop law, which we are going to learn in the later part of the video. But you have to understand the laws are not difficult. You just have to follow the rules and you will be fine, right? Okay, so let me just read that out. What are the things that is written over here? Kirchhoff law help us to understand how current and voltage work within the circuit. Yes, so how the current is going to flow. So in this particular example, how the current is going to flow, how if the current is going to flow like that, or what will be the law or what will be the rules in order for your current to flow, right? That is something which Kirchhoff law help us to understand. Secondly, it also talks about voltage. It also talks about voltage. What is going to be the voltage over here? What is going to be the voltage over here? So with the help of that, we can actually find out the current inside the circuit and also the voltage that is flowing or that is being there, right? Okay, great. Kirchhoff laws are used to analyze complex circuits by reducing it to some basic concept that we already know. So basically, Kirchhoff laws are used to analyze some complicated circuits, right? So we can analyze this circuit, how the current is flowing, where the current is dividing, right? So very nicely we can actually analyze complicated circuit with the help of Kirchhoff's law, right? So these are some advantages of Kirchhoff laws, right? Okay, so Kirchhoff actually gave two laws. First one is your KCL, that is Kirchhoff's current law. Kirchhoff's current law. Second one is KVL, that is Kirchhoff's voltage law. This is also known as Kirchhoff's loop law, right? So your Kirchhoff's current law is based upon conservation of charge, right? And Kirchhoff's voltage law is actually based upon conservation of energy. Don't worry, we are going to understand them one by one, right? Okay, so let's try to understand the first law. So Kirchhoff's law is the topic. Let's try to understand the first law, that is your KCL, Kirchhoff's current law. Kirchhoff's current law, KCL, right? This law is based on the conservation of charge. Basically, it is based upon conservation of charge. Conservation of charge means I'm actually talking about current here. You have to understand that, right? Okay, so let me just read the statement here. It states that the sum of incoming current at a junction is equal to sum of outgoing current. Sum of incoming current at a junction is actually equal to sum of outgoing current, right, through that junction. Okay, so the first thing we have to understand here is what is this junction over here, right? Then only we'll be able to understand the whole picture, right? So what is junction? So according to, if you search any dictionary, right, you will get to know junction is actually a point where two or more things are joined, right? Normally junctions are there. We see junctions in railway stations, right? So what is a junction? So according to this definition, junction is a place or is a point where two or more things are joined, right? Let me give you a simple example. So I have two examples over here. Okay, I have point A and point B. So from point A, I have this line joined, I have this line joined, I have this. So I have three lines joined from your point A. So according to definition, a point where two or more things are joined. So a point where two or more things are joined. So basically your A automatically becomes a junction. I hope you guys can understand, right? Sometimes we call it nodes, right? Sometimes node or you call it junction, it's one and the same thing, right? Okay, a point where two or more things are joined. So this automatically becomes your junction. What about point B? You guys can see from point B, you have 1, 2, 3, 4, 5, 6 lines joining. So this point is also automatically become a junction. I hope you guys can understand that, right? Okay, great. Now let's read the statement again. It states that sum of incoming current at a junction is equal to sum of outgoing current. So sum of incoming current at a junction is equal to sum of outgoing current. So let me just very quickly just do that. For example, let's say some I current, let's say some I current is coming through that point, and at the junction, what is going to happen? Let's say the I current is divided. Let's say this is some I1 current here, this is some I2 current here. So like I said, your first law is based upon law of conservation of charge. So obviously, according to conservation of charge, charge can neither be created nor be destroyed, right? So if I current was coming at the junction and it is being divided into I1 and I2, then I can, with the help of conservation of charge, I can write my I current is actually equal to I1 plus I2. Is that a yes or no? And this actually verifies the statement sum of incoming current. So this current was incoming, right? Sum of incoming current is equal to the sum of outgoing current. These currents are your outgoing current, right? So the I is actually equals to I1 plus I2. I hope you guys can understand that. Yes. Okay. Let's take one more example. Let's say here some I1 current came, here some I2 current came, and let's say these are the four outgoing ports, right? So this I1, I2 current, divided into some I3, I4, I5, and I6, right? So sum of incoming current will be equal to sum of outgoing current. I hope you guys can understand. So I can simply write I1 plus I2. These are your incoming current, right, is actually equal to I3 plus I4 plus I5 plus I6. I hope you guys can understand. These are your outgoing current. Outgoing current. Yes, I hope you guys can understand that, right? Okay, let's take one more example. So let's say this is my junction, this is my point C. Let's say incoming currents were I1 and I2, right? And outgoing currents were I3, I4, and I5, right? Sum of incoming current at a junction is actually equal to sum of outgoing current, right? So I can write I2 plus I1 or I1 plus I2, whatever way you want to write it, is equals to I3 plus I4 plus I5. Is that a yes or no? I hope you guys can understand that. Yes. Okay, so this is what your Kirchhoff's current law states, or it says that sum of incoming current at junction is equal to sum of outgoing. This is all your Kirchhoff's first law, that is your Kirchhoff's current law, talks about. I hope that's understandable, right? Okay, if that is true, let's move to second law, that is your Kirchhoff's KVL, or we also call it Kirchhoff's loop law or Kirchhoff's voltage law, right? This is Kirchhoff's voltage law. So this law is based upon law of conservation of energy. You already know energy can neither be created nor be destroyed, but can be, inside a closed system. Obviously we're talking about inside a closed system. So inside a closed system, energy can neither be created nor be destroyed, right? It can be transferred from one form to another form. That is something which we already know, right? So let me just very quickly read the statement. The algebraic sum of all the potential differences in a closed loop is equal to 0. This is what your Kirchhoff's voltage law states, that the algebraic sum of all the potential differences in a closed loop is actually equal to 0. Okay, mathematically you can simply write it, summation of all the potential differences in a closed loop from 0 to n will be equal to 0. Okay, let me make you guys understand with a simple example. So I have a simple circuit over here. So I'm taking an example of a simple circuit here so that you guys can understand it much better, because we already know the values for simple circuits, right? Okay, so I have a simple circuit. The first thing is you have to read the statement, the algebraic sum of all the potential differences in a closed loop. So the loop must be closed, right? So I have to choose a loop first. That is the important thing, right? So I have a simple circuit over here, right? So what I will do here is I will choose the loop. So let's say this point is 1, this point is 2, this point is 3, this point is 4. So firstly I have chosen a closed loop. I have chosen a closed system, right? So in this closed system, that is 1, 2, 3, 4 and back to 1, this is my loop, right? Or I can say this is my closed system, right? In the closed system, let's read the other parts, right? The algebraic sum of all the potential differences is equal to 0. The algebraic sum of all the potential differences, right? So let me just very quickly, so potential differences across your 1 and second point, let me just write it, potential difference V1 minus V2 plus potential difference across your V2 and V3, right? Potential difference, let me just write that here, potential difference V2 minus V3, right? Okay, then potential difference across 3 and 4, that is plus potential difference of V3 minus V4. I hope you guys can understand, plus potential difference across your 4 and 1, right? So I'll just write it, potential difference across your 4 and 1. So in that closed system, the addition of algebraic sum of all the potential difference comes out to be 0. So the answer comes out to be 0, right? This is what your Kirchhoff's voltage law states. Okay, now let's try to very quickly do that. So basically V1 minus V2, that is V1 minus V2. So between V1 and V2, what is the potential difference here? There is a resistance over here. So before that, first thing is that we have to, the current must be flowing, right? So the current is being flown over here just like that, right? Okay, the current is flown. Now so you have to understand, I current is here and there is a resistance. So what is the potential difference across your 1 and 2? So resistance and current. So by Ohm's law, can I say the potential difference across V1 and V2 is actually equal to IR? I hope you guys can understand, right? So I can simply write V1 minus V2. Let me just write that there so that you guys can understand much better, right? Okay, just a minute. Okay. So let me just write that here. V1 minus V2, that is potential difference across these two, points will be, can I write it to be I times of R? That is by Ohm's law. Yes or no? I hope you guys can understand, right? Okay, great. Now, potential difference across my 2 and 3. There is actually nothing in between. So the potential of 2 and potential of 3 are same. So can I say potential difference across, second and 3 is actually same? So I can write my V2 minus V3 is actually equal to 0. I hope you guys can understand that, right? Okay, great. Now, let's talk about the next one, potential difference across 3 and 4. Okay, so between your 3 and 4, I have an internal resistor and I have a cell, right? So let's try to very nicely try to find out the value of potential difference over here, right? So I can say I have a internal resistor, right, which is having a resistance of R and I current is flowing, right? So one thing is very clear, I times of R will be coming plus there is a battery source, but you have to understand, as I'm going from here to here, I'm actually entering the negative side of the battery, right? I'm not entering the positive side, I'm actually entering the negative side of the battery. So this battery has an EMF E. So should I write E or should I write minus C, right? You have to understand, as we all know, your current also has direction, and we are talking about 1 2 3 4. We are going in a loop. So this is important. We will study this, how you have to do it. So this is important that we take a loop over here. So our loop is 1 to 2, 2 to 3, 3 to 4, 4 to 1. So as we are going in the loop, we are entering the negative side of the battery over here, right? So when it is negative side of the battery, we take our potential difference to be negative, right? So don't worry, just for a time being, just believe me, we will actually understand all these things, right? So your IR plus minus of E, right? Okay, great. Then what is the potential difference across your 1 and 4? So potential difference across your 4 minus 1 is actually equal to 0 because there is nothing over there. So I know I got all the values here. All I have to do is put the values back here. V1 minus V2 is actually IR plus V2 minus V3 is actually 0 plus V3 minus V4 is actually IR minus of EMF plus 0, and that comes out to be equal to 0, right? So I can very simply write it over here that IR plus I small r is actually equals to the EMF, or you can take your I common, this is R plus R is equals to your EMF, or I can simply say I is equals to EMF upon R plus R. Now this formula we already derived in our previous video. If you guys remember, we started the video with this. Yes or no, right? So with the help of Kirchhoff's law, we are able to get the same result as we were able to, we were able to derive it, right? So for a simple circuit, we were able to do it. And obviously this law is actually for complicated circuits, right? So we will definitely going to get the values of current from these law. So I hope you guys understood both the laws, that is Kirchhoff's first law, that is Kirchhoff's current law, and Kirchhoff's loop law. So in the next video, we will try to do lots and lots of questions where we can understand Kirchhoff's law. We will do some numericals based upon your complicated circuits, right? I hope you understood the video. If you have any doubt, you can comment it down in the comment section. That's all for today. Thank you and have a nice day.